Hello and welcome to Robert's Tech. This is a demonstration of a locomotive control system that I designed. It is an analog system, not digital. It is not wireless, and it has a multitude of control features. Three modules that you see ahead of you. This one, of course, is the old American Flyer transformer. That's powering everything. Then down here we have the control module, and then this module here is the telemetry module, and I will explain each of these as we go along in the video. Right now the locomotive is on the track. It's in its idle smoke mode, putting out smoke, just sitting there. This is similar to a DCC command system, so the power stays on the track all the time, so you have the headlamp and the caboose lit even though it's not moving. As I increase the throttle, the train will move. I have simulated chuffing sounds. It's a fan-driven smoke system, so the fan puts out puffs as it puts out the chuffing sound. The telemetry has a speedometer. A working speedometer tells you the speed of the locomotive. We have track voltage here. We have the smoke box temperature, the tender temperature, and the voltage. So that's a telemetry. It's actually receiving signals from the locomotive. This is the control box, where of course we have throttle, which at this point is being controlled by our American Flyer transformer through a adapter circuit. I do have a local throttle here that I can switch to if I want. We also have sound effects. We have locomotive whistle. When I stop the locomotive, you can see it goes into its idle smoke mode. I can turn on the bell, put it in reverse, and then reverse the engine. Turn the bell off. We have a cylinder drain simulation where it lets the steam and water out of the cylinders. And I also have a decoupling feature. So if I want to decouple the cars, I can push the decoupler and disconnect the cars. And I can back up and connect the cars again. Release the steam, sound the whistle, switch on the bell. Got the cars connected, and off we go again. You notice the speedometer, as we increase speed, will come up, showing you the speed of the locomotive. Our telemetry is showing temperatures inside the locomotive. We have 228 degrees in our smoke box, 117 degrees. These are Fahrenheit degrees. And the tender, where all the electronics is housed. The tender is reading 17 volts in its internal circuitry. The other reading here is track voltage, which is an RMS track voltage. And then we have our speedometer. Now this is an adapted tachometer, so it's a times 10, where if it says 4, then it's 40 miles per hour. And this is an actual speed that's being sent from the locomotive, and I can demonstrate that. So if I stop the locomotive here, you see the speed drop to 0. If I were to hold the locomotive and try and run it, we're not getting any speed until I let it go, and then it will read the speed. So speed is actually being measured on one of the axles in the tender. And if you watch it carefully, you'll notice you hear the locomotive slow down, speedometer drops down. If you hear the locomotive speed up, there it goes. It'll show that it's going faster. So this is a feature that no other system has through the rails. Like I said, this is a through the rails analog control system. Here on our control box, see the different functions. We have our whistle or horn, our steam release or cylinder drain, our decouple button, the bell. And another unique thing to this system is the smoke is fully adjustable from the control panel. So I actually control the amount of smoke coming out here and the speed of the smoke coming out of the stack during idle. So right now we have pretty light smoke. I could turn this up. You can also tell how much power you're putting in to the smoke system by watching the temperature on the telemetry display. So let's stop the locomotive in front of us here. And you can see it's getting a little heavier because I turned it up. I can actually adjust the speed of the smoke coming out. Okay, watch that. So there we can really get the smoke coming out if we want. Let's put the fan up higher. So that's really pouring out now. And that's adjustable from the control panel here. And I can really crank the smoke up so when it's going down the track, you'll get a lot of smoke. More than you probably want. But the nice thing about it is, you know, if you want smoke, you can crank it up and smoke, and if you don't want smoke, you can actually turn it all the way down and it'll shut off. So you have your choice, and it's all adjustable right here from the panel. Another thing we can do, as I said, right now I'm using our old American Flyer transformer for both the power for the system, and I'm reading the signal from the throttle there and putting it into my box and controlling it. But I can, if I don't use that throttle, I don't want to use the throttle, I can throw a switch here and I can control it locally. I can throw the switch here on the side and I can control it locally with this throttle. And again, we can turn the bell on, throw it in reverse, back up. Let's turn that off. Turn the bell off. Make sure we're in forward. Hit the decoupler. Okay, the cars are gone. Now when the locomotive backs up, we have an automatic reverse light that comes on in reverse. So if I want to back the cars into a siding, I can put it in reverse. I can back the cars into the siding. Turn the bell off. I can decouple the cars. Put it forward. Drain the cylinders. And we're off without the cars. And I can throw the bell on, put it in reverse, and go get the cars again. Switch over to my Flyer transformer for control. The voltage shown here on the controller is the bus voltage inside this controller itself. All of these things are information that tell me how the system is doing. The telemetry reads all the different temperatures and voltages, and it does give you warnings. Like at the moment, it's telling me my smoke system is running a little hot, because we've had it up high for quite a while. So I've got a red warning light here, I've got a warning light here. And, you know, I can turn the smoke back down and get it cooled off, or I can just shut the smoke off entirely. It'll take a while for it to stop coming out, because it's pretty well heated in there. But right now I've got the smoke shut off, and as we run it, it'll diminish. So, to my knowledge, this is probably the world's only bi-directional analog system where we're sending commands to the locomotive and the locomotive is sending information back to us for our readings. And it's completely analog. There's no digital signals at all. So that's a pretty complete demonstration of the system. I hopefully will make some more videos showing a little more about how the system was put together. So thanks for watching this edition of Robert's Tech, and we'll see you next time.